For any chemical reaction, you already know that the reactant combine together to make the product. And all chemical reactions follow this law, the law of conservation of matter. Basically, the amount that you put in on the reactant side must equal to the amount that you put on the product side. Now let's explain that in terms of mole. Basically, the number of moles of each element on the reactant side must equal to the amount of moles of that same element on the product side. And if the moles is the same for each of those elements on both sides, so does the mass, so does the number of those atoms. So that is basically the law of conservation of matter. In order to prove that law really exists, we have to balance a chemical reaction or chemical equation. In this video, we are going to focus on how to balance a chemical equation. Now let's look at how to balance a chemical equation. Well, there is only one rule when it comes to balance a chemical equation, and that is you can only change the coefficient number, and that's the number in front of the chemical formula. And that's the only method that you allow to change to manipulate the number of atoms on both sides of the product or the reactant. So, as always, if we're trying to balance a chemical reaction, we need to make a list of what's on the reactant side and what's on the product side. To make the list for the reactant and the product, we draw the line between the reactant and the product. And based on the law of conservation of matter, the list would be the same for both sides. They just have different numbers of each of the elements. So in this case, we have calcium, hydrogen, and oxygen. How many calcium do we have? 1. How many hydrogen do we have? 2. And how many oxygen do we have? 1. Okay? Over here, the list would be the same, CaHO. But the number of moles of each element would be different. In this case, we have 1 calcium. How many hydrogen do we have? Well, 2 right there. And we have another 2 more over here that give us a total of 4 hydrogen. What about for oxygen? We have 2 right there, so that gives us a total of 2 oxygen on the product side. Now, this would be a violation of the law of conservation matter. But once you balance it, you can prove that the law of conservation matter really exists. The first type of element that we always balance first is any metal, before we even touch any non-metals. Now, we're going to go to the last thing that we're going to do. The last type of substance that we're going to look at is the elemental hydrogen and the elemental oxygen. These two will all be the last thing that we are going to look at. What about the rules in between? Now, this rule can sometimes be effective in terms of using to balance a chemical equation, but most of the time we just ignore it. So let's look at this particular problem. Well, calcium is already balanced already. What about hydrogen? Well, hydrogen is an elemental form, so we save this last. So let's go to oxygen. Over here we have 2, right? And over here we have 1. So we go up here and find where oxygen is. It is in this compound right here. So what to go here will give us 2 oxygen as well. So we can set up an equation, an algebra expression to solve for the coefficient for those who struggle with math. So in this case, I know it has to be equal to 2. And we can represent this in terms of x, or a question mark, right? And if you notice right here, right, there's a subscript right here that's 1. So 1 times 1 in terms of x will give us 2. And of course, x is going to be 2. So we can cross that out and give us ourselves a 2 for the coefficient. So now let's recount. Because you put a coefficient there, it would affect every single element in that compound. So we have 2 times 2, that gives us 4 hydrogen. What about 2 times 1? Now that gave us 2 oxygen. So again, this is a list for us to keep track. Now, are all of them balanced? Yes, the calcium is, the hydrogen is, as well as the oxygen. What do we do with all the one that doesn't have a coefficient? Well, of course, it's going to be 1. And that's all we have to do. And notice how we ignored these 2 steps right here, because we didn't really use it in this case. So different type of reaction require different strategy to balance the chemical reaction. In this case, it's very similar, right? So we have the same thing. Let's make a list. Based on the law of conservation matter, both sides must have the same list. And Ba in this case 1. Hydrogen again is 2. And oxygen is just 1. And then over here Ba we have just 1 only. How about hydrogen? We have 2 here and 2 there that give us 4, and oxygen give us 2. And the same thing that we did before, because I pretty much just changed from barium to calcium. So the same approach. Notice how the problem is very similar to this problem, that I replaced calcium with barium. This is just to show you how I can manipulate the chemical reaction to make the problem different. But the approach to solve it is pretty much the same. So again, the same thing. We always start with the metals, which in this case, the barium is already balanced. And we have to save all the elemental one last, which in this case is your hydrogen. So we have to go to the oxygen. So we have 2 oxygen over here. What's going to go right there? What's that going to be? So that subscript right there is 1. So 1 times x equal to what? 2. So notice how I set them equal to each other, right? So x is going to be 2. So therefore this right here must be 2. And if that's 2, that's going to change the values hydrogen to 4, as well as the oxygen to 2. Now you have a balanced chemical reaction that proves the law of conservation matter really exists. Now let's try another problem that is very similar, but it's completely different. So again, we make the list. Based on the law of conservation matter, the list of the reactant and the product must be the same. So we have K, H, and O. And over here will be the same thing, KHO. But their number is going to be different. Over here, 1, H will be 2, and O will be just 1. On the product side, K turned out to be only 1. H turned out to be 1 plus 2 give us 3. And notice how hydrogen, I add 1 here to that 2 right there because they are on the same product side. Give us a total of 3, and for oxygen is just 1. So in this case, what do you notice is that the K is balanced on metal first, which we did. And we're going to save this last as always because it's an elemental form, okay? Where oxygen is balanced as well. So now we have a situation where we have to balance this last. As we mentioned before, we're going to balance the elemental hydrogen last. So let's determine the coefficient right here. An equation. Well, first of all, we know that this side, right? Let me set up right here. This side has 2 hydrogen, okay? And over here, what do we have? We have 1 hydrogen coming from there, from this one right here. But over here, we have a subscript right there. We can say that this is 2x, where the x is going to be this one right here. Can we solve for x in this case? Let's do that. So in this case, this minus 1 and minus 1 give us 1 equal to 2x. And what is x is going to be? Well, x is going to be 1/2. So this right here is going to be 1/2. And now we have a fraction. So our answer is 1, 1, 1, and 1/2. But there's a way that we can turn that fraction into a whole number. And to do that, we multiply the entire reaction, all the coefficient, by the denominator of that particular fraction. In this case, the denominator is 2. So I'm going to multiply everything by 2. So this is going to give me 2. This is going to give me 2. This is going to give me 2. And this is going to give me 1. So let's count all the elements all over again because we have multiplied all the coefficient. So in this case, potassium, which is K, I get myself 2. For hydrogen, I have 2 times 2 give myself 4 hydrogen. How about the oxygen? 2 times 1 give myself 2. That's on the reactant side. Now it's on the product side. 2 times 1 here give us 2. And what about for oxygen? 2 times 1 here give us 2 as well. And what about for the hydrogen? 2 times 1 give us 2. Okay. And we also have 1 times 2 that give us a total of 4. So there you go. We have used a fraction to solve for the coefficient. This is probably one of the most complicated problems that you will see in terms of writing an algebra expression to solve for the coefficient. Now let's see if you can do this problem by yourself using what we just learned in the previous problem. Well, first thing first, we need to make the list. And of course, the list is going to be the same, NaHO. If this is NaHO, over here will be NaHO as well, based on the law of conservation of matter. Well, over here we have 1 Na, we have 2 hydrogen, and how many oxygen do we have? 1. Oh, we have 1 Na, but for the oxygen we have only 1. What about for the hydrogen? We have 1 and plus 2 give us a total of 3. And the Na is balanced as well as the oxygen. So, of course, this one is going to be last, okay? And now the question is, what is the coefficient that go over here on this particular elemental hydrogen? The same thing, we have to set up an equation so that we can solve for that x values. And of course, when we set up our algebra expression, we are comparing between the reactant side and the product side. So reactant equal to product. And on the reactant side, how many hydrogen do we have? We have 2. And on the product side, we have 1 here. So we have 1. And we have that 1 plus 2. 2 times x. So 2 times x. What is x going to be? Using your basic math skill, we bring the 1 over here, minus 1, give us 1. And over here, we have 2x. And x is equal to 1/2. So right here must be 1/2. Okay? So if I were to rewrite this, I would have 1 Na plus 1 H2O equal to 1 NaOH plus 1/2 H2. And this is still the right answer using the fraction. But when you go to college, your professor wants you to put in the whole number. And how to get rid of this fraction is to multiply all the coefficient or the entire reaction by the denominator, which is that 2 right there. So that is a 2. So this will turn into a 2. This will turn into a 2. This will turn 2 because 2 times 1 right here, they all equal to 2. And 2 times 1/2 give us 1. So our answer is 2Na plus 2H2O produce 2 NaOH plus 1 H2. So this is probably one of the hardest problems that you will see in this class. Now let's try some of the easiest problems that you will see in this class. Well, first of all, let's make a list. We have NH, so N and H. Of course, on this side, we have N and H as well, based on the law of conservation of matter. It must be the same, but the number is different. So in this case, we have 2 hydrogen. In this case, we have 2 nitrogen. We have 2 hydrogen. And here we have 1 nitrogen. And what else do we have? 3 hydrogen. In this case, we don't have any metal, and we're going to go straight to the next non-metal we have, which is nitrogen. And nitrogen over here has 1, and over here has 2. So what go here will give me 2. So to set this up as a fraction, so that way you apply your math skill, on the reactant side, we have 2 nitrogen right there. And on the product side, we have, what is this? The subscript here, 1. So 1 times x. What is this x gonna be? So x is gonna be 2, of course. So this right here has to be 2. And if I have a 2 right there, 2 times 1 give myself 2 nitrogen, and 2 times 3 get 6 hydrogen there. So the nitrogen is balanced. Now let's balance this last, as we promised before. This will be the last thing. So let's write this as an algebra expression again. We have x right here, okay? I'm gonna make this over here. So on the reactant side, what do I have? I have 2 times x. So 2 times x is equal to what on the product side? On the product side, I have 6. And what is x gonna be? 6 over 2, and that gonna be what? This can be simplified into a whole number, which is 3. So x is gonna be 3. And if that's the case, 3 times 2 give me 6 hydrogen. And that's how we balance it out. Isn't that easy? A lot easier than the other one, isn't it? Now let's try to balance one of the most common chemical reactions that you will see, which is the formation of water. And everybody loves water because we need water to survive. So again, the same thing, make a list. We have H and O, and over here we have H and O based on the law of conservation of matter. And over here we have 2 hydrogen and 1. And we have 2 oxygen. Over here we have 2 hydrogen and 1 oxygen. In this case, we have elemental hydrogen and elemental oxygen. But the hydrogen is already balanced, so we have to look at the oxygen. In this case, okay, let's see if we can make a fraction out of this. We have a variable over here, which is x right here, right? Let's make an expression. Well, this is going to be 2 times x, okay? 2 times x is going to equal to what? Well, on the product side, it's just 1. So what is x going to be? X is going to be 1/2. This right here is going to be 1/2. And how do we get rid of this 1/2 right here? We multiply everything by the denominator, which in this case, it is 2. So we have 2 times blank, which is 1 right there, so it's 2. So 2 times 1/2 give myself 1. And 2 times blank, which is 1, so give us 2. So our answer is 2, 1, 2. And is that right? Well, let's check. 2 times 2 give us 4 hydrogen, and 1 times 2 give us 2. And over here we have 2 times 2 give us 4 hydrogen, and 2 times 1 give us 2 oxygen. Isn't that easy? Now let's try another easy one. This one is a very fun reaction. This is a combustion reaction that we make a lot of fire and flame and heat. So in this case, we have CHO, CHO, see, CHO, and CHO. Based on the law of conservation matter, it has to be the same. In this case, on this side I have 1, and how many H do we have? 4, and how many O do we have? 2. And over here I have 1 C, and how many hydrogen do I have? Well, 2, and how many oxygen do we have? 3. 2 plus 1 give myself 3. Again, we don't have any metal, so we balance the first non-metal, but the first non-metal is carbon, so it's balanced already. And we always save what last is the elemental hydrogen or oxygen. In this case, it is right here, so this is going to be last, okay? So now let's look at hydrogen. Over here we have 4, and over here we have 2. And this is where our hydrogen is, right? So what is going to go right here? I forgot the space right there. So let's do this. Let's set up our algebra expression comparing the reactant side and the product side. So reactant equal to product. In this case, on the reactant side, I have 4 hydrogen here. And on the product side, I have the subscript of 2 times x. 2 times x. X is going to be what? 4 over 2. This gives us 2. So this right here must be 2, okay? And if we have a coefficient 2 right there, that number of hydrogen now is going to be 2 times 2 give us 4. And for the oxygen, 2 times 1 give us 2. But we also have 2 over here that give us a total of 4 oxygen. So now we go on to our last one. What is going to go right here? Again, let's set up an equation where we can solve it out until x. On the reactant side, I have 2 times x right here, 2 times x, okay? And on the product side, how many oxygen do we have? 4. So 4 right there. So what's x going to be? 4 over 2 give us 2. So x right here, it is 2. So 2 times 2 give us 4. And there you go, it's balanced. So that's how you use your math skill in chemistry to balance chemical reaction and to prove the law of conservation matter really exists. The number of moles of reactant must equal to the number of moles of the product. As well, because the moles are the same on both sides, as well as the mass is going to be the same as the number of atoms is going to be the same as well. And that is the law of conservation of matter.